Well, guys, good morning. Hey, so grab your homework packets, and we are going to spend whatever time you guys deem necessary going through these reaction type things. First of all, we'll look at identifying reaction types. Then we'll move into writing and balancing these things. But guys, let me make sure that you're clear on this. What you're doing on the next couple pages is exactly what you're going to be doing in lab today. So guys, if you have unanswered questions now, those will probably get brought out again when we go over the lab. So guys, my strong encouragement to you is that you aggressively get your questions answered so that you're prepared well for the lab we're about to do. So any questions about the types of reactions on the front of this? Did I tell you that there weren't any combustion reactions, but that was just my oversight? Okay, so guys, with that said then, let's go here. Letter number 1 we did together, so I suspect you were good on that. And then guys, please remember that all of the decomposition reactions that you looked at, you could not predict the products for. There's no way for you to predict the products for decomposition reactions, except for today, you're actually going to be doing decomposition reactions in lab, and then you'll be able to figure out what they do because you'll actually be doing the lab and you'll see the products form. But on the homework, there was no way for you to do that. So guys, any questions 1 through 5? Are we okay 1 through 5? Going once? Going twice. Where at? On here. Yeah. So, yeah, great. No, I know. Great question. And the answer is even more complicated than just talking about charges. The reason the answer is more complicated is because this is a molecule and not a salt. So what we're actually doing is bonding these together covalently, which kind of is about charges, but it's even a little more complicated. So we'll talk about it, but don't worry about it. So what we need to do, does your periodic table say hydrogen could be +1 or -1? Okay, so there's only one way really for this to happen. And the reason comes back to Lewis dot structures. If you draw the Lewis dot structure for nitrogen, it looks like this. And hydrogen then can fit in here in 3 of these locations. And when it does, hydrogen is actually going +1 and nitrogen is actually going -3. But the way to know to pick those charges is actually to draw the Lewis dot structure. And I didn't expect you to get to that point. So that's how number 8 works. But if you didn't get there, you're okay. I won't throw that at you like on the test or anything like that. That's a great question. So why is the nitrogen first if it's negative? And the answer is because it's not a salt. So when we say that it's always positive first and negative second, that's if it's ionically bonded and a salt, and this is not, and therefore the rule is actually the thing that goes in the middle is typically first. But then with that said, when we write down water, we know that the oxygen's in the middle, and now it's not first. So molecules get a little bit wacky. You don't need to worry about it. But that's the reason why the nitrogen is first, is because it's in the middle. Yeah? It would be wrong, yeah. But you aren't supposed to know that. So I told you the products are water and sulfur dioxide. So if you split it into something else, understand that's wrong, but I also don't expect you to know that. But I do expect that you can write water and sulfur dioxide and then balance it. And if you remember, I gave you those products. So, but it's a great point, right? How are you supposed to know what it breaks into? You could do 2, 3 things, whatever. That's why I had to tell you what it breaks into. So guys, what else? What did you break it into? Hydrogen, sulfur, and oxygen?
Well, I broke it into
Yeah?
I was just wondering, like, how would you know that if you didn't tell
Exactly. And so the answer is you wouldn't, other than today we're going to go do some of this stuff in lab, and then you'll see the products and you'll know. Guys, other questions at all? Yes, ma'am. So question number 11 on the table. So similar deal. How are we supposed to know? And actually, this is another one like Jessica's question where you'd have to draw the Lewis dot structure. But what actually happens is this, and again, I'm not expecting you to come up with this, but this electron actually, or this proton, hydrogen, transfers to the NH3, and you end up with NH4 plus forming, and then chloride forming, and then those bond together ionically. So it's a shifting of a hydrogen and then an ionic bond. But again, I don't expect you. You've seen it now, but you won't see it again. So you're okay. But given if you could come up with the product, you then should be able to balance it. And it's already balanced. Guys, anything else? Y'all good? You're sure? Okay. So guys, please make a note to yourself to record your homework before midnight tonight. And guys, all you need today is a pencil. Don't try to do this in pen. All you need today is a pencil. Let me unlock your homework recording screen, get you a copy of the lab, and we are going to be next door in about 10 minutes. All right, so that is now open. And this, and get rid of that and grab a hold of this and do this. All right, so guys, all you need today is a pencil and the lab handout. Here we go. You betcha. So we do have an assembly Friday, is that true? Okay. It's in person, right? Yeah. Oh, yeah. All right. Did I still get 4? Did these guys? Ah. Okay, guys, the next 10 minutes are mine, and then we're going to get you next door. So, first of all, name and period A1, please. On your, I don't know why that little place for A1 is so small, but you'll make it work. So, guys, do this with me. Turn to page 2. Look at the data chart. So, guys, here's the scoop. I gave you the most open-ended data chart in the history of data charts. You'll notice that down the left-hand side, it simply says procedure number. And if you look right above, you'll notice that it says parts 5 and 6. So, guys, fundamentally, what's going on is this lab is 6 little mini labs. And for each one of those mini labs, you can write down whatever you want. I simply made it organized around before reaction and after reaction. But guys, I'm not going to look at your data chart. That is literally your space to write down whatever you believe is worth writing down. But then, of course, the question is, to what end? Turn it over to page 3. So guys, here's what you're going to do. For every one of the 6 reactions that you do, first of all, don't miss this. See where it says reaction type up above? You may want to circle that, at least on the first one, so you don't forget. And so right next to that reaction type equals, you're going to be identifying the type of reaction that you carried out. And then, guys, in the space, you are going to write the balanced equation that represents that reaction. So the data that you collect is anything you need to write down to get you to this. Does that make sense in your head? Okay, but notice, guys, this. Up in the instructions, in the calculations, it says include subscripts indicating the phase of each reactant and product. And guys, we've never done that before, so I want to explain to you what this looks like. So guys, imagine, and this is not part of the lab, but imagine in lab, you took a big old balloon of hydrogen and you lit it on fire. How would you write the balanced equation for that? Well, guys, if you have a balloon of hydrogen and you light it on fire, what is it reacting with? Oxygen. So your other reaction would be oxygen, and this is a classic synthesis reaction, and it forms water. But then, guys, we need to balance it. 2 hydrogens, 1 oxygen. So we need a 2, and we need a 2, and it would be like this. And then we would identify that as synthesis. But then, guys, we've got to add subscripts. Solid, liquid, gas, or aqueous. So let's talk. Hydrogen, solid, liquid, or gas? Gas, right? So all you're going to do is you're going to come over here and you're going to subscript a G in parentheses. Guys, that's where it has to go. After the substance, subscript in parentheses, G for gas. Then, guys, of course, oxygen in the air around us is also a gas. Now here's the question. What do we put for water? And the answer is, it depends on what you saw. So guys, if this balloon lit on fire and water rained down out of where the balloon used to be, then the water was produced as a liquid. But guys, if you did this reaction and you didn't see water droplets, that means that the water then immediately boiled and it became a gas. So if you saw drops, you would put L for liquid. If you didn't see anything, then G for gas. You get the idea? Yeah. Yeah. Mm-hmm. Sure, it just means it made 2 molecules. So for every 2 molecules of hydrogen that go in, 1 molecule of oxygen goes in and 2 molecules of water come out. So it's still individual water molecules. There's just 2 of them for every 2 and 1 that go in. Yeah?
So both the L and the G for liquid and gas
yeah.
both be correct?
No, and actually the answer would be G, because this produces so much heat that the water immediately boils and it's released as steam. So you wouldn't see water droplets, so it wouldn't be liquid. But again, that depends upon what you experience, and that's the whole point of this, that you want to be right. And guys, this is the tricky bit. You want to be writing down information that not only tells you what went in and out, but also whether it's a solid, a liquid, a gas, or aqueous. And that's this information. Yeah. We're going to talk about that. So guys, let's remind ourselves, what does aqueous mean? Dissolved in, not water, but dissolved in water. And let's talk about that as we go. So guys, pages 2 and 3, do you understand what you're doing? Okay, so now guys, page 1, grab something you can write with, and let's set you up for success. So guys, notice that there are 4 and then 2 on the next page, little mini labs. Each one of these has its own cleanup procedure. Guys, please don't screw this up because we're going to end up in trouble if we do. So part 1, really, oh, and by the way, I should tell you, guys, when you walk into the lab, you're going to see at the front counter, there are 6 sections on the supply counter from left to right. So guys, please make sure that you grab the stuff from where it should come from and then put it back so other people can get to it. So guys, part number 1 is really easy. Get a piece of sandpaper, sand down a 2-centimeter piece of copper wire, grab your crucible tongs, put it in the hottest part of your Bunsen burner flame, let it go for 90 seconds, put it in the trash, and you're done. Number 2. Get a 5-centimeter strip of magnesium ribbon. Using your tongs, put it in the burner flame, light it on fire. Then guys, once it's burning, allow the reaction to complete, then put the ash in the trash. Now guys, here's the deal. When you guys remember the magnesium, right, that we put in the crucible? When it lights, it burns at about 1300 Celsius. So guys, as that's burning, do not hold it over the floor, because if it falls out of your tongs, it'll melt a hole in the floor. If it falls on our countertops, it's totally fine. So hold it over the countertop as this is burning, and then just put the ash in the trash. Then guys, part 3, place approximately 1 centimeter. Guys, that's the width of your pinky. Place approximately 1 centimeter of copper 2 carbonate in a clean, dry test tube. Guys, it's got to be dry. Do not try to wash out a test tube. Circle dry in number 1 on part 3. Guys, it's got to be dry. If you get it wet, you'll never get it dry, and this won't work. So what you're going to do is you're going to take a test tube and you're going to put 1 centimeter down at the bottom of copper 2 carbonate. Then guys, using your test tube clamp, the thing that you can use to hold your test tube, you're going to heat this compound strongly for 3 minutes. Then guys, this is where this gets interesting. Then you're going to remove the tube from the flame, and then guys, read steps 4 with me. Step 4 says test the test tube for the presence of carbon dioxide using a burning wood splint. So guys, here's what you're going to do. You're going to cook this for about 90 seconds. And then what you're going to do is once 90 seconds are up, you are going to test the test tube for the presence of carbon dioxide. And here's how you do it. Colton, make sure you're hearing this. What you're going to do is you're going to take a pair of tweezers and you're going to grab a little popsicle stick. And you're going to grab a hold of that popsicle stick and you're going to shove it in your Bunsen burner flame and light it on fire. Then guys, you're going to shove that down into the test tube. Now guys, carbon dioxide is not flammable. So if you shove the burning wood down inside the test tube, and if there's carbon dioxide in there, what's going to happen to the flame? It's going to go out. So guys, if the flame goes out, that is a positive test for carbon dioxide, which would then be one of your products. Then guys, reading along, finishing up step 3, when you're done, run the splint underwater and then put everything in the trash. You guys good? Okay. Then guys, part 4. And please, I know these are a lot of little steps. Read carefully, take your time, do good work while you're in lab. So guys, part number 4. Stand a medium clean dry test tube in a test tube rack. So now guys, the blue test tube racks are next door. You're going to stand a test tube up in that thing. And then guys, step number 2, you're going to add 2 centimeters of 6 molar HCl to the test tube. Guys, please don't get this on you. If you do, you've got 5, maybe 10 seconds as the acid eats through the oils on your skin, and then it's game over. So guys, please be very, very careful. This is really strong hydrochloric acid, but it has to be. Then guys, reading along, step 3, carefully drop 4 small pieces of zinc into the acid. So guys, we're going to put 4 pieces of zinc down here inside the acid. And then guys, this is where this gets interesting. Step number 4, invert another test tube over the reaction tube. Step 5, collect any gas for 30 seconds. Then step 6, test the product for the presence of hydrogen using a burning wood splint. So guys, this is what this looks like. You are then going to take, once this is in there, you're going to take another test tube and you are going to invert it over the top of this test tube. So this is going to be here. You're going to get them in really close proximity and you're going to hold it here upside down for about 30 seconds. And guys, you're going to see this bubbling. And as it bubbles, that gas is going to rise and it's going to fill this test tube. Now, if that gas is hydrogen, is it more or less dense than air? Hydrogen is less dense than air, so check it out. If you do this, where does the hydrogen go? Up into the air. So you're going to leave this flipped upside down. So you're going to hold this here for 30 seconds. You're going to let it fill up. Then you're going to keep it like this. And then guys, what you're going to do is you're going to take another burning wood splint and you're going to shove it up inside this test tube that may or may not contain hydrogen. Now guys, if it contains hydrogen, what's it going to do? It's going to explode. And guys, it's not like and rip your arm off. It's actually really cute. It's really but it is startling the first time you do it. So guys, please, as you're doing this step, your lab partner needs to be saying to you, hey, remember this is going to explode. Because if you don't remember, it will startle you, and people are throwing test tubes all over the lab because they're like, ah! And so guys, please, gonna blow up, gonna blow up, gonna blow up, stick it up in there, and just enjoy the explosion. You'll probably want to do it a couple times, do it again. But again, guys, remember, this is going to explode, okay? Then, guys, reading along to the bottom of part 4, it says, please underline step 7 in part 4. Don't screw this up. Guys, please pour the solution and the zinc into the waste bucket, then take the splint, run it underwater, throw it away. Guys, the waste bucket is back in the fume hood. Just dump it in there. I'll take care of it. Just dump the acid and the zinc into the waste bucket in the fume hood. Then, guys, you flip it over again, part 5. Add 2 centimeters of 1 molar. Oh, we forgot to talk about this. Guys, go back to part 4. Sorry, I forgot you don't know this. Go back to part 4. And guys, read step 2. It says add 2 centimeters of 6 molar HCl. Guys, what does 6 molar tell you? So what does molarity tell us? The concentration, which means what? What subscript will that get? If it's 6 molar, that tells us how many moles are dissolved in a liter, right? So if it's something dissolved in water, what will its subscript be? Aqueous. So guys, you may want to write that down next to step 2 in part 4. The acid subscript is aqueous. Okay, now moving over to part 5. Check it out. Step 1, add 2 centimeters of 1 molar copper 2 sulfate. What subscript will that get? Also aqueous. To a clean, dry test tube. Step 2, carefully add another piece of zinc to this solution. Then step 3, place the test tube in a rack. Allow the reaction to continue for the remainder of the lab. You'll come back to it in just a moment. Then, guys, when you are finally done, pour the solution and the zinc into the same waste bucket you put the acid and the zinc. While that's going on, you'll go down to part 6. Add 1 centimeter of 0.1 molar zinc acetate to a small test tube. Part 2, add 1 centimeter of 0.1 molar sodium phosphate to another test tube. Then pour them together. Then that mixture, which should be step 4, that goes in the waste bucket. Then go back, record your observations for part 5, pour that in the waste bucket, and then you're all done. So guys, questions about what we're doing in lab? Okay, so here's the deal. 2 things. First of all, turn to the front page of the lab. This is not due on Thursday. This is due on the Monday after spring break. So now the question is, why am I giving you so much time to write this up? And guys, the reason is because the level of detail that it takes to write this lab up well is very high. Almost as high as the level of attention that it takes to do well in lab. So guys, as you're going through this lab, you are always engaged. You're asking each other questions. Hey, what information do we need to write these balanced equations? You're following steps. You're paying attention to what you're doing. But then, guys, when you're done writing up these balanced equations, it can be a little tricky to do them well. So guys, I'm giving you until the following Monday so that you have the opportunity to ask questions, get support, the things that you need to do this well. So guys, when we get next door, it's going to be goggles first, and we're just going to start, and we're going to do 1 through 6, being careful and cleaning up as we go. Yeah?
There's a video on the lab online, right?
There will be, but it won't be there until Wednesday. I won't have a chance to record it until Wednesday. But there will be. And Sam, you need to make sure you leave your headphones here. Don't have those in lab. Yeah, London. No. Yeah, the conclusions are the only time we will ever type conclusions in this class is that one that we did for the React or for the phase change lab. Otherwise, we never do. So, guys, anything else you need from me? Okay, let's get next door.